So the complicated schema changes has been deployed. You can check for the um, admin editability from backend. Again, can go and launch studio or manage environments. Launch studio. So it looks set right now. So at this point, the schema is available and the content management also is available. So let's start with a new code flow called code named JAID. We'll be making a backend directory. Start a new debug session. Rename it as setup. We'll create the necessary skeletal directories. While at it, we'll create the front end folders also and the front end skeletal directories. Resuming backend helper work. So I've checked out the source repo in my machine. We'll be using it for the reference files instead of navigating to Chrome and copy pasting from there. Let's use Shadow CLJS to set up a hackable node library for admin and the backend. We would need node fetch npm dependencies to execute GraphQL APIs. Excuse me. Let's create another window, rename it as node console. Let's create another window for code. Now the core namespace may appear unassuming, but it has a lot of deep stuff. One among them is sci-eval string integration, which gives the front-end users the ability to evaluate EDN and have a serverless Lambda execute eval it. The namespace also has admin code that is helpful to administer fixtures from data available in CSV files. Core will be the main namespace, and you can see the basic queries in the end. The namespace above that we saw uses many other related namespaces. Util CLJ is where you define macros. This is where CLJ's integration really shines, as you have full macro system to take away or tame the cognitive load. You may follow this in your local machine. uh, because I've already set up a SRX MLC branch of Daily Hassan locally. The CLJS is a shim reference file for the util namespace we just created. Let's create a namespace for CSV lib handling. Let's create one for GraphQL common APIs. We need the complicated code schema, etc. As mode queries for the project we have created. So let's get the complicated code from the main project. CodeGen will recreate the new schema. We can copy over the files from the main project. Let's install and check whether everything is running okay. Yeah, the build seems to be completed. Let's go to the code window, create another split pane, start the build here. Build is done. Let's go and start the node in the console. So this is actually the completion of the code flow JID. Let's create another window for Git. Let's check in the code. Add the usual suspects to gitignore. Add the files. Prepare a commit. Go to GitHub and create a repo called figamp sc2 backend helper. Again, it should be a private repo. Add remote. And push the changes in. Now let's administer some data. So you see that there is this GraphQL endpoint and there is this API key which will be needed in the core namespace. So let's get the API key. So I always fear this double J because that's known to be problematic. Now what we do is begin with step 3, execute it, see whether it's executing. Now we make the tbg constant namespace by executing step 4. To check whether they were created okay, what we do is just check whether this seems okay, looks fine. Let's see whether this seems okay, looks fine. Okay, now let's uncomment it uh, and see whether it compiles okay. So I think it got compiled. Now we need to upload some images. We need to create a S3 bucket called figamp sc2. So let's go to create bucket figamp sc2. We need to uncheck this. In block public access, uncheck the block public access and then create it. Now let's copy over some. So figamp sc2 bucket got created. So let's copy over some files from my local downloads, some images to that bucket. Now we need to open a sample bucket policy. Let's open a sample bucket policy, another tab, and in this tab we'll go ahead and copy the policy. So here we've created the bucket called figamp sc2. In permissions we can edit and copy it from the policy here. Just do a paste and do a edit. So instead of www.codesoup.com, you can just say figamp sc2 and save. Once it's saved, we can actually try to browse any object, whether it's loading up as a image, from say a cognito tab. Yeah, it looks okay. So we have successfully made a public bucket. Now it's time for us to create the subcats. Then create the POIs later. Let's create the POIs. Okay. Now go to step 2 to create the channel partners and execute step 6 again to upsert. Now we check in the code. Now GraphQL APIs are very expressive and empowers the front-end team to build UIs. However, certain other use cases, especially the ones that require interfacing with third-party entities like HubSpot, WhatsApp, etc., may require you to deploy REST APIs and webhooks. You may do so as well using AWS Amplify. Such APIs will be useful to integrate with external webhooks. Let's switch back to uh, the Taku code flow and extend it by adding a REST API. So let's create another window for code. Let's create another window for white. Let's run white. Great. Let's create another one for get. Now let's add API. Select REST, select default for friendly name, WA webhook for path, WA webhook for function name, Node.js hello world, yes advanced settings, yes other resources. Let's give API access and npms package manager. So it's REST, friendly name, let it be default. We'll say WA webhook. We'll say WA webhook again. Node is fine. Hello world. Say yes here. We want resources access to API. We need all the three. We don't want recurring schedule. We don't want layers. We don't want to configure environment variables. Secret access function can access. No. NPM is the package manager. We don't want to edit the lambda now. No need to restrict API access. No need to add another path. Okay, so this is where the function code has been added. Let's make it into a ES6 style. Let's add the replace the MJS namespace completely with the one that I have for reference. Now let's copy the example CLJS from this. Let's make the edits to figamps SC2. Next we add npm dependencies to package. Make a reference folder and copy event example. Let's add everything and prepare a commit. Let's push the code and see whether it has started the build. It has started the build. So in conclusion, there are two ways in which we enable backend code flows. The primary setup is codenamed JID. This is where we write Node.js lambdas that import common JS modules targeted via the node library target of Shadow CLJS build. The second code flow is where we demonstrated using a ES6 import through a library called NBB. This lets node eval in quick and dirty code written in Clojure. We used code flow VERD for this setup. So this build is likely to take time and we'll resume once it's done.